Hello, everyone. My name is Adam Safran. I am a postdoctoral research fellow at the Johns Hopkins Center for Psychedelic and Consciousness Research. I am also a research fellow with the Kinsey Institute at Indiana University. Today, I will be sharing some thoughts on pleasure, pain, desire, and the brain. What is pleasure? What is pain? What is desire? How are these things related? What can the brain tell us about this? We've done extensive work, us scientists, um, trying to find the mechanisms of different affective phenomena. Ken Berridge's work is particularly notable in taking something which might seem simple like reward and decomposing it into separate processes. So he would distinguish between something he calls incentive salience, which would correspond subjectively to something like wanting or desire, which is how much an organism is motivated to do something. This is associated with particularly associated with the neuromodulator dopamine and the brain area, the ventral stratum or the nucleus accumbens. So people will sometimes say dopamine is pleasure, but actually that doesn't seem to be the case. It seems to be more associated with something different: motivation, wanting, desire. Pleasure, which is inferred by a happy face that an animal will make. It kind of goes like this, I think. And this is associated with another structure called the ventral pallidum. Rather than dopamine, this appears to be modulated by opioids. So your either external or internal opioid systems in the ventral pallidum seems to be most strongly associated with an organism experiencing pleasure. But why? So these two areas, the ventral stratum and the ventral pallidum, they're part of a broader circuit called the basal ganglia, which has basically provides a constant brake on the rest of the brain. And different areas of the brain have to basically disinhibit themselves by getting excited. And based on the amount of value you think that might be available or the organism thinks, they'll have different levels of fluctuating dopamine and different levels of opioids, and this would influence tendencies towards this brake being taken off. So a little complicated. It's very complicated, but the basic idea is that for the ventral pallidum would be it's one of the near final points in the circuit before action is released. And so with opioid signaling in that area would basically release this brake, allow action to flow, and will also, though, hit the midbrain dopamine areas. And when that dopamine is released, it will both further disinhibit potentially and reinforce whatever just happened, the good thing. And so functionally speaking, that makes some sense, like why that might be associated with pleasure, but still, why does it feel good? Why does it feel bad? Why does it feel like anything for that kind of process to take place? So in terms of neuroimaging, people have looked at the brain under different states of pleasure and pain. And there's a kind of a list of usual suspects called the pain matrix of areas that show up whenever people are experiencing aversive states. It tends to include areas like the insula, the cingulate, the amygdala, and these areas seem to be active in conjunction when people are experiencing pain. However, these areas also activate in response to many other things that don't have anything to do with pain. It seems it's just whenever anything is salient, these areas are coming online together, and so we're not really able to explain, and it's not clear we're much further in explaining why pain is the way it is, and why pleasure is the way it is, or desire. So potentially, so I've been exploring these computational frameworks of predictive processing. Don't worry about this figure. I'm not going to get into too much of it, but the basic idea is you can treat cortex as this kind of predictive hierarchy where it's sending these predictions downwards, it's these red arrows, about what is expected. So each area of the brain has these expectations about what it's going to receive. It sends these downwards towards the modalities, towards where the sense data first inputs, and then it suppresses these sensations. So you might think, well, why would it do that? Um, well, in this scheme or this setup of predictive coding, it ends up being very efficient if all you need to do is communicate where you got it wrong. And so it's like you're generating these predictions throughout the brain, and then and if you don't get contradicted by sense data, you just assume that's what it is. However, when the sense data is otherwise, this will generate a prediction error, which will move upwards away from the modalities as an observation, and this is your information, which will be used to update your predictions. And this is proposed to be happening at all levels of the brain in parallel, this hierarchy of increasingly abstract predictions, which are moved passed downwards and then updated via prediction errors from the sense environment. In these images here, you'll see these red swaths or beta frequencies, or they're these rhythms between around 13 to 30 times they go a second, and the blue is alpha frequencies. It's these other rhythms, about 8 to 12 times a second. But what these are thought to do is encode your beliefs, what you think is going on. And this, and your subjective experience, is thought to be some subset of these beliefs, potentially a certain coordinated set of these beta rhythms, potentially within this broader envelope of alpha rhythms, which would allow you to experience different things. So this kind of predictive processing view has been extended to interoception, or as part of explaining what it is to feel and emotions. So the idea here with interoception is, so right here you'll see different exteroceptive modalities, vision, touch, hearing. But there's also information from the inner body, from your gut, your heart, the vessels, reading different amounts of inflammation or tension or various things. And this information from the viscera, from the internal milieu, seems to get bundled together, and then it goes up to the brain, largely via vagus nerve. It'll go up to the brainstem through particular areas of parabrachial nucleus, nucleus tractus saltaris, don't worry about it. And then it'll make its way to the posterior insula. And when it makes it there, you have a hierarchy on top of that, going from the back to the front of the insula, of a hierarchy of predictions of increasing degrees of abstraction. And what this hierarchy will be doing is trying to predict what is going on with the moment-to-moment changes of your autonomic or your interoceptive, your inner body. And the idea that this could form the basis for feelings, for emotional experience, would make some sense. And that people use words differently, but I tend to think of emotions as global organismic modes, which allow for adaptive responses to classes of situations. So there's ways that you should be configured to respond for an anger situation, a fear situation, disgust, happiness, sadness, etc. These are different classes of things that would have different appropriate responses, both in terms of what your autonomic and your internal state, your interoceptive state should be, as well as, sorry, I'm getting a call, don't worry about it, as well as in the body itself, like the kinds of modifications that you should do for your pose. So for instance, if you're in an anger situation, your heart rate should be going up, and your hands, maybe they should be ready to go. That would be an example. So this figure here is actually, I find it fascinating. They had a lot of people draw on top of these body sketches where they feel their emotions. And this is the agreement across individuals, where people tend to feel different emotions. And so the idea that interoception would be really strongly determining makes sense. And that if emotions are these adaptive changes of mode in response to classes of situation, well, the most adaptive thing, almost the very criteria of adaptiveness, is staying alive. And the most relevant things for staying alive is your heart okay? Do you have enough food? How are you doing all the other like aspects of homeostasis, the range of conditions you need to be in to keep being an organism, to keep staying alive? And so that this should be one of the primary determinants of emotion. It makes a lot of sense functionally, And it makes sense even developmentally, in that, let's say we were thinking of an infant, that's the primary consideration. It's really all it can maybe think of is like, how hungry am I? How cold am I? And these experiences, these interoceptive bases of emotion, uh, that would be a lot of, it would contribute to what it feels like. So I would suggest that pleasure and pain could be thought of as excessive prediction error resulting in your predictions falling out of sync with each other and becoming more chaotic or entropic or dissonant. So you have these different rhythms encoding your beliefs, and they could potentially go across purposes. So here it's like, if the rhythms are harmonious in phase, this is constructive interference, this would be like a kind of harmonious state. But potentially, they could go across purposes and if they get disorganized, if there's too much prediction error for them to handle. And so this would be a highly entropic state. And so this state of increasing entropy, specifically in these predictive hierarchies over your body maps, over your interoception, over your exteroception, like all the different parts of your body, when those are unharmonious, when the disharmony is increasing, that would be pain. But when the harmony is increasing, or the disharmony is decreasing, that would be pleasure, roughly. Maybe not roughly. And so I won't be able to get into the details right now, but I recently proposed a model that all affects have a kind of, this was published in the journal Entropy, where all affects have a kind of synesthetic quality. So synesthesia is the experience that some people have when their modalities get mixed up. And so some people will see colors associated with numbers and letters. That's one form. My claim is that your interoceptive states, because the information is not really precisely localizable in space and time, there's no need to know like exactly where in my gut the pain is. It's just my gut is bad. And there really was no need for that precision, because you can't do much about a particular pain in your gut, but an overall bad gut that you can do something about. So the idea is this poorly localizable information will get infused into other modalities. And so there would be this kind of coupling between your interoception and the rest, the other ways of feeling your body, and maybe even infused into objects in the world. And that this coloring of other aspects of experience by your interoceptive state, this would be part of the phenomenology of pleasure and pain. So I'm not going to be able to get into this too much. This is the pain matrix on the left and interoception on the right, but the idea would be that the Cingulate could be thought of as this integrator for overall levels of how much is harmony increasing or decreasing. And this would be a core aspect of motivation, of basically making the organism shift what's happening, making it more likely to select some things and not others based on this overall amount of error. And with reference to the earlier idea of like the pain matrix being non-specific, the pain matrix, one idea would be that pain and pleasure shouldn't be thought of as separate for cognition, that there is no pure cognition without affect, that all cognition is affectively driven, infused with pleasure and pain. And this makes some sense in that you're cognizing for a reason. You want to prioritize some things and not others. And the subjective experience of pleasure and pain associated would help you know of the things you're cognizing and remember how good and bad things were. So one more thing I would mention is I talk about this in that paper in Entropy. I would think of desire potentially as a particular species of pain, as a kind of error signal that could become pleasure through its annihilation. And so you would always be moving back and forth between pleasure and pain. When you take away pain, that would be pleasure. When you take away pleasure, that would be a kind of pain. And there would be this interchangeability. And part of motivation, desire, would be a kind of pain that you want to do something about so that you can have pleasure through its removal. Some people would find this surprising, but others wouldn't. Many of the world's wisdom traditions have said very similar things. Perhaps they were onto something. Thank you very much for your time and attention. Please don't hesitate to contact me if you have any questions. Thank you.